Alright, we're going to talk about the surface area of prisms and pyramids today. We have formulas that we can use. For a prism, the lateral surface area is the perimeter of the base times the height. The total surface area, you still have that lateral surface area plus all prisms have two bases. So you get the lateral area plus 2 times B, big B, which is the area of the base. So you get the area of two bases, they're congruent, and then you have the lateral faces. Lateral is just side. So all the lateral surface area is the surface area around the sides of the figure. If it's a prism, the sides are typically rectangles or some type of parallelogram. For a pyramid, the lateral surface area is 1/2 times the perimeter of the base times the slant height. And slant height, it's kind of like the height of the faces, the lateral faces. In a pyramid, the lateral faces are triangles, and so it's the height of those triangles. Total surface area, again, you have the lateral surface area plus pyramids only have one base. So you get the lateral surface area plus the area of the base. So those are the formulas we'll be using. And I kind of already talked you through this a little bit, but the lateral surface area is the sum of the areas of the lateral faces. So it's everything except for the bases. It's just the faces going around the sides of the figure. Total surface area is the sum of the areas of all the faces. So the lateral surface area plus the area of the bases. And if they just ask for the surface area, then they're referring to total surface area. Even if you don't see that word total, they just say surface area by itself, that's what's understood. Alright, a prism is a three-dimensional figure with two parallel congruent polygonal bases. So there's always two bases, and those two bases are going to be parallel to each other, they're going to be congruent, and they're going to be polygons of some sort. And those bases are connected by lateral faces that are parallelograms. All the prisms we're going to deal with, the lateral faces will be rectangles, which is a type of parallelogram. But they don't have to be rectangles. They can be any type of parallelogram. Alright, so let's talk about classifying. This is a prism. It has two parallel congruent bases that are in the shapes of rectangles. So here is one base, and here is the other base. They are parallel and congruent to each other. Every prism has two bases, and we classify prisms based on the shape of their base. So since the bases are in shapes of rectangles, we would classify this as a rectangular prism. Let's talk about the parts. Actually, let's classify this one first, and then we'll talk about parts. On this one, the bases are here and here. This is a base, and this is a base. Remember, for any kind of prism, you have to have two parallel congruent bases. The bases don't always have to be on the top and bottom. They can be on the sides. Notice that these two triangles look like they would be congruent, and they look like they're running parallel to each other. Those are the two bases, and then you got the rectangles going around the sides of the figure. Those are the lateral faces. So in this case, this prism, the shape of the base is a triangle, so this is a triangular prism. Okay? Alright. The edges that go around the base, the sides of that base, are called base edges. So this is a base edge. This would be a base edge, this would be a base edge, same thing up here. This would be a base edge, and this one too, and this one, and this one. The edges or segments that are not parts of the bases but connect from one base to another, those are called lateral edges. So this would be a lateral edge. Lateral edge. This is a lateral edge, this one, and this one, all lateral edges. So over here, same thing. All of these segments that are going around the base are base edges. So this is a base edge. And then the segments that are not part of the bases but run from one base to another, that connect the two bases together, those are called lateral edges. Now it's hard for me to label everything without too much overlap, so I'm just going to write this little note here. The unshaded faces are lateral faces. So the ones I've shaded in are bases. The ones I did not shade in, those are lateral faces. So when we're talking about finding the lateral surface area, that would be finding the area of all three of these unshaded faces. Or in this figure, it would be the front, the back, the left side, and the right side. Those four faces are lateral faces. All right, on example 2, it says classify the prism below, then find its lateral surface area and total surface area. So first off, we need to recognize that every single face on here is a rectangle. So this is going to be a rectangular prism. Okay. Now, rectangular prisms are unique in comparison to others in that really you could pick any two pairs of parallel congruent sides to be the bases. It doesn't have to be the top and bottom, although that's the most common. But I could use this, and this is the base, and that would make all of these the lateral faces. Or I could use the bottom and the top as bases, or I could use the front and the back as bases. It really doesn't matter. It does for every other one that we're going to deal with, but not with the rectangular prism because they're all rectangles. Just for doing what most people would do, let's use the bottom and the top as the bases. So when we find lateral surface area, this is the formula. We want to find the perimeter of the base and multiply it times the height. So for the base down here, perimeter, you just add up all the sides. 8, 6, 8, and 6. And when we add all those up, you should get 28. So the perimeter of the base is 28. And then the height of the prism is 2. So we're multiplying the perimeter of the base times the height, 28 times 2. So the lateral surface area is 56 units squared. Any kind of area is always units squared. Area is a two-dimensional measurement. This is a three-dimensional figure, but we're only finding a two-dimensional measurement because we're just finding the area of the surface. So the area is units squared. All right, total surface area is perimeter of the base times the height plus 2 times the area of the base. Now, we already did this work. We already found that the perimeter of the base times the height is 56. So I can go ahead and substitute that in there. And then all I really need to do is find the area of the base so I can plug that in. Okay, well the base is a rectangle. Area of a rectangle is length times width. So the length and width of the base are 8 and 6. And 8 times 6 is 48. So now that I know that the area of the base is 48, I just substitute that in over here in place of big B. Big B represents area of the base. And now I have everything I need. So we got 56 plus 2 times 48. And that should give you 152. So the total surface area is 152 units squared. Lateral surface area, 56 units squared. Total surface area, 152 units squared. All right, let's look at example 3. It says find the lateral surface area and total surface area of the cube below if each edge is 5 centimeters. Now a cube is kind of a special three-dimensional figure. It's a type of rectangular prism where all of the faces are congruent squares, where the length, width, and height are all congruent. So this is a cube, and every single edge is 5. All of the edges are 5. All right, so it is a type of prism. So you need to remember that when you go to the formulas, because we didn't write down a formula for area or surface area or lateral surface area of a cube. So you need to understand that a cube is a type of prism and use the prism formulas. So for perimeter of the base 5 plus 5 plus 5 plus 5. So you can either do 5 plus 5 plus 5 plus 5, or you can know you got 4 faces, each one of them is 5, and you can multiply those to get the perimeter. So another perimeter is 20. And then the height of the cube is 5. So we got 20 times 5 is 100, and there is your lateral surface area. Now for total surface area, remember this is the formula. So remember the lateral surface area is part of it. We've already done that part. And now we need to get the area of the base so that we can plug that in there. The base is a square, so you can do side squared, or you can do length times width, however you want to do it. Either way, it's going to come out to the same thing. The side is 5. 5 squared is 25. So the area of the base, 25. We plug that in there and find out what that gives us. Well, 2 times 25 is 50. We add that to 100. We got the total surface area is 150 units squared. And actually, I'm writing units squared, but they told us this was in centimeters, so I don't need to be that generic. I can write centimeters squared on each one of these. Sorry about that. All right, let's look at the next example. Classify the prism below, then find its lateral surface area and total surface area and round to nearest hundredth if necessary. All right, this is a triangular prism. I know it's a triangular prism because I see nothing but triangles and rectangles. Prisms have rectangles going around the side or some type of parallelogram, and then it's got the 2 parallel congruent bases. So I see 2 triangles that look parallel and congruent to each other with a bunch of rectangles going around the sides. So the triangles are the bases. So this is a triangular prism. Alright, lateral surface area of any prism is perimeter of the base times the height. Now don't forget, the base is not the bottom. The bases are these triangles. So when I do the perimeter of the base, 8 plus 12 plus 8. The perimeter comes out to 28. And then the height of the prism is 4. And that confuses some people as well, because most people are used to seeing the height go vertical. And most of the time that would be correct. But the height is going to connect from base to base. Remember, base and height are always perpendicular to each other. So it should be, if the base is running vertical, then the height is going to run horizontal because they're going to run perpendicular to each other. So the height is 4. Just think about if I tipped this to where the base was the bottom now. Then this would be going vertical like you would be used to seeing it. So we got 28 times 4 is 112. And that is the lateral surface area. Total surface area. Here's the formula. We already took care of the lateral surface area, so we got that part covered. So we just need to find the area of the base and plug that in there. Now this time the base is a triangle. So formula for area of a triangle is 1/2 times base times height. Now, a little bit tricky here. On this triangle, I do not know the height of the triangle yet. I know the base of the triangle is 12, but I don't know the height of the triangle. So we need to find out what this is before we can find the area of it. Well, anytime you got an isosceles triangle and you drop that height in here, you end up splitting this side into 2 congruent parts. And that's because you have, when you draw this height in here, you split that triangle into 2 right triangles. Notice their hypotenuses are congruent. They're sharing this side, so by hypotenuse leg, these triangles are congruent to each other, which means that these corresponding parts down here have to be congruent. So they're each going to be half of that 12, so 6 and 6. And to find the height, what I'm going to do is just focus on this right triangle. I have 2 sides of that right triangle. I can find the third by doing Pythagorean theorem. C is always the hypotenuse. 8 is the hypotenuse here, so I'll put that in for C. The 6 can go in for A or B, does not matter which. So 6 squared is 36, 8 squared is 64. I want to get A all by itself, so I got to get rid of this 36. It was being added. Oops, I'm saying added, so I'm adding. it was being added, so we do the opposite operation and we subtract it. And 64 minus 36 is 28. And then we got to get rid of the squared. So again, opposite operation. And the opposite of squaring is taking the square root. Alright, square root of 28 is approximately 5.2915, something like that. Alright, so let's say that is A, that was this side of the right triangle, which is our height. We needed that to find the area of this triangle. So the base for the triangle was 12, and we just found out the height of the triangle is approximately 5.2915. So we got 1/2 times 12 times 5.2915. And when we do that, we should get approximately 31.75. Alright, so when I plug that into our formula now, we got the area of the base. Now we can finish this off and find the total surface area. So we got 112 plus 2 times 31.75. And that brings us to 175.5. I should have kept extra points over here. I should have just left it at 749. Let's do that. Let's leave that at 749. 31.749. Because we want to round to the nearest hundredth at the end of the problem. And if I round to the nearest hundredth in the middle of the problem, it's going to affect our answer. So let's type that in differently. 112 plus 2 times 31.749. We get 175.498. And it's actually not going to affect the total value. 8's big enough to make the 9 round up. So 9 becomes 10. I got to carry the 1 over. But we're rounding to the nearest hundredth, so I want it rounded there. Alright, so there's our total surface area. Alright, so we've dealt with prisms. Now let's talk about pyramids. A pyramid is a three-dimensional figure with one polygonal base and triangular lateral faces that meet at a common vertex. So here you got the one base, and then you got a bunch of triangles going around the sides that all come up to this point and meet at this vertex right here. So a pyramid, you got one base, a bunch of triangles coming up to a point called a vertex. Alright. This is a square pyramid because the base is in the shape of a square. It has base edges of 10. So each edge along this base has a length of 10. It's got lateral edges of 13. Each one of these lateral edges is going to be 13. And we want to find its slant height. Now the slant height is the height of those lateral faces, the height of those triangles. So this right here, this that I'm tracing in red, that is the slant height that we were trying to find. Alright, notice this slant height, half of this base edge and this lateral edge form a right triangle. And we should know 2 of the sides already. We can do Pythagorean theorem to get that third side. Now, that slant height is going to split this side, that 10, into 5 and 5. So when I'm focusing on this right triangle, I have side lengths of 5 and 13, and I want to find that other side. Now this is one of our Pythagorean triples we learned a long time ago, so if you memorize those, you don't have to do any work. You can skip straight to the answer. The hypotenuse is 13. Put that in for C. 5 can go in for A or B. Does not matter which one. 5 squared is 25. 13 squared is 169. I want to solve for A. I want to get it all by itself, so I got to get rid of that 25. It's being added, so we subtract it. And then we want to get rid of the squared, so we do the square root. And you should get that the slant height is 12. 12 units. And remember, we had a Pythagorean triple, 5, 12, 13. 5, 12, 13. So you see the 5 and the 13? We can know the other one's going to be 12. Alright, let's turn to the back page. And let's look at example 6. It says, find the lateral surface area and total surface area of the square pyramid below. Alright, again, it's called a square pyramid because the base is in the shape of a square. Lateral surface area for a pyramid is 1/2 times the perimeter of the base times the slant height. Okay, perimeter of the base. It's a square, so if this is 12, all 4 of these sides are 12. So I can just do 4 times 12, and I know the perimeter of the base is 48. Now I need the slant height, and the slant height has not been given to me yet. When they draw this height down here, okay, it splits that distance in 2. It comes right down in the middle. So if this is 12, I know that this piece right here is 6. So I'm looking at a right triangle where I know these sides are 6 and 8. Again, this fits one of the Pythagorean triples we've done this year. So if you remember that, you can skip straight to the answer here. But if not, let's do Pythagorean theorem. I don't know C. I don't know the hypotenuse. Though the 6 and 8 are A and B. 6 squared is 36. 8 squared is 64. And when I add those together, I get 100. I want to get rid of the squared so I can solve for C. So I do the opposite operation. Square and square root are opposites. Square root of 10, 100 is 10. So we got 6, 8, and 10. And remember, one of our Pythagorean triples was 3, 4, 5. And any multiple of 3, 4, and 5 is a Pythagorean triple. All right, so we got the slant height is 10. Now we have everything we need to find the lateral surface area. 1/2 times 48 times 10 should get 240 for the lateral surface area. Okay, for total surface area of any pyramid, you take the lateral surface area and you add the area of the base. So we already got the lateral surface area is 240. We just got to find the area of the base. Well, the base is just a square. An area of a square is side squared. I know the side is 12. 12 squared is 144. So I'm just adding 144 to the lateral surface area. It should give us 384. So the total surface area is 384 units squared. All right, last one. It says the regular triangular pyramid below has a slant height of 9 centimeters and a base edge of 6 centimeters. Find the lateral surface area and total surface area and round to the nearest hundredth if necessary. All right. The fact that it's a regular triangular pyramid means that base is a regular triangle. It means it's equilateral and equiangular. So if there's a base edge of 6, I know each one of these base edges is going to be 6. It says it has a slant height of 9, so I know this segment right here is 9. All right, so there's the information we have. We want to get the lateral surface area, so we need to do 1/2 times the perimeter of the base times the slant height. Well, perimeter of the base is this triangle down here. All 3 sides are 6, so it's 6 plus 6 plus 6, or 3 times 6, which is 18. So I got the perimeter of the base times the slant height, which was 9. So we got 1/2 times 18 times 9. Lateral surface area comes out to 81 units squared. Actually, no, these are centimeters. Excuse me. I gotta start checking those units better. Centimeters squared. Okay, for total surface area of a pyramid, you got 1/2 times the perimeter of the base times slant height plus the area of the base. You're taking the lateral surface area and adding the area of the base. So we already know all of this comes out to 81. All I need to do is find the area of the base now. Now that's the tricky part. The base is in the shape of a triangle. Area of a triangle is 1/2 times base times height. And for this triangle, I know the base is 6, but I don't know the height of the triangle yet. Don't know the height of the triangle. Need to find it. Well, you got an equilateral triangle. Anytime these sides are congruent and you draw that height down, it's going to divide this side into 2 congruent parts. So 3 and 3. So I have a right triangle right here with side lengths of 6 and 3. I should be able to find this piece right here. Focusing on this triangle right here for those of y'all that have a hard time seeing it. Focusing on this triangle right here. So for Pythagorean theorem, C is always the hypotenuse, and the hypotenuse here is 6. The 3 needs to go in for A or B. Does not matter which one's which. Alright, so 3 squared is 9. 6 squared is 36. We're solving for a, so I want to get rid of the 9. It's being added, so I'll do the opposite and subtract it. And then I got to get rid of the squared, so I'll do the opposite operation and take the square root. And the square root of 27 is approximately 5.196. Now I got that number for the height of the triangle. So now I can find the area of that triangle. The base, remember, was 6, the whole thing, because we want to find the area of the entire base, not just that red triangle that I outlined. We usually just focusing on that because you need a right triangle for Pythagorean theorem. But we're going to find the area of the whole base, and the base for that is 6. And we just found out the height is approximately 5.196. So 1/2 times 6 times 5.196 comes out to 15.588. So there's the area of our base. We're going to plug that in over here. And we can add that to the 81. Now the directions tell us to round to the nearest hundredth. So if that's the case, I only want to keep 2 numbers after the decimal point. That 8 is big enough to round up. So I'm going to round that 8 up to a 9. And there's our final total surface area, 96.59 centimeters squared.